here's a problem where we solve for the strength of an electric field based on how much force it puts on a test charge. So in this kind of problem, they tell you the size of the test charge. So here we go, we have the amount of the test charge. Okay, now this was nice. They actually told you it was a test charge. And instead of using Q1 or Q2 or QA or QB, now we're still using Q, but when we talk about a test charge, we call it Q prime. So that's what I'm going to label it in my list of given information. And then they tell you that it's experiencing a certain force. So we'll put down that information. And then we're being asked to find the magnitude or amount of the electric field at that spot. So when the variable we're using for electric field strength is just capital E. So if you look at your formula sheet, there's a couple formulas that involve capital E. But the one that we have enough information to solve for is E equals force divided by Q prime. So this is a really easy plug and chug one once you figure out which equation to use. So we're using 2.0 times 10 to the negative fourth over 5 times 10 to the negative 6. Okay, so then you get out your calculator. Then we get 40. Now, if we look at sig figs, we just need to add either write it like 40 with a dot after it, or write it in scientific notation. And the units are newtons over coulombs. There isn't really a nicknamed unit this time. Okay, now all it asked for was the magnitude. This time it did not ask for the direction. And that's because it didn't tell us any information about where this positive test charge is located. You know, it just told us that this positive Q prime is just hanging out here in space. You know, is it being pulled to the right? Is it being pulled down? We just don't know. So we're not able to tell this time the direction of the electric field. Okay, that's it for that one.